Okay, so today we're going to go over solving word problems that involve coins or something similar, something that has value, right? So the first thing we want you to do is define your variables. That's an important skill that we want you to practice. And then we want you to write an equation. And then we want you to solve the equation. And then we want you to write your answer in a complete sentence. Right? So we want to do all those three things with every single problem. So let's look at number one. Yarly has $4.70 in her purse. She has 9 fewer dimes than she has quarters. How many of each coin does she have? You might be able to figure this out just kind of by guessing and checking and guessing and checking and guessing and checking, but we want you to practice writing an equation and then solving that equation. So basically, what is the problem about? The problem is about the fact that Yarly has some dimes and she has some quarters, right? And then specifically it says that she has 9 fewer dimes. So she doesn't have as many dimes. Matter of fact, it's 9 less, right? It's 9 fewer. So if she had, say, 19 quarters, so if she had 19 quarters, she would only have 10 dimes because she has 9 fewer, right? It has to be 9 difference. So just kind of understanding the general idea of the problem. So basically we have dimes and quarters. So we're going to right, this is defining your variables. This is the first part A. So part A, we want to define our variables. So we're going to say let Q represent the number of quarters. So then the number of dimes, right? The number of dimes, it says the dimes, there's 9 fewer than there are quarters. So there's 9 fewer than there are quarters. So Q minus 9 is the expression that will represent how many dimes there are. And then how much does a quarter, what's the value of a quarter? Doesn't the value of a quarter, like normally we put 0.25, that's the value of a quarter? And then what's the value of a dime? Isn't the value of a dime, normally we'll put a 0 in front, 10 cents, right? Isn't that how you write 10 cents for a dime? And isn't that how you write 25 cents for a quarter? So that's what a value of each of those coins is. So she said that the total value is $4.70. So the equation that we're going to write, so this part is the defining your variable parts. The equation is going to be, we got to add the quarters with the dimes, and it has to equal $4.70. So we have to change it into money. So we have to say 0.25 times how many dimes or quarters we have, which is Q, plus 0.10 for how much a dime is worth, and then we have Q minus 9 dimes, and we want that to total to be $4.70. So that is the actual equation. Now we have to solve that equation. So notice that we put the value, right? A value of a quarter is 25 and the value of a dime is 10. And then the number of quarters is just Q and the number of dimes is Q minus 9. Right? So if you had 3 dimes, wouldn't you multiply 3 times 10 cents to say it's 30 cents? If you had 5 dimes, wouldn't you multiply 5 times 10 cents to say that you have 50 cents? So this is the equation that we get. Now we have to solve it. So I'm going to need some more room. So let's pick this over. Oops, I don't know how much room I'm going to have. So I'm going to rewrite that. And so I got 0.25 Q plus 0.10 Q minus 9 equals 470. And wouldn't it be smart to get rid of all those decimals? So if I multiply everybody by 100, it's going to move the decimals twice. We just got done learning about decimal busters, and here's a perfect opportunity to get rid of the decimals because it's just going to move every decimal twice, right? It's just going to move every decimal twice, so that's going to give us 25Q plus 10Q minus 9, and then 470. And then no more decimals. And then we can use the distributive property. add 90 to both sides. So how about if we add 90 and combine like terms at the same time? So these two terms are like terms. So we got 25Q and 10Q. So why don't we add those together? That gives me 35Q on this side, and I get 560 on this side when you add these two together, and I got to divide by 35. And when you divide by 35, I could use my reducing skills, but why don't we just grab a calculator and do that, and let's see what we get. So that gives us 16. So we'll use the calculator for that one, and that gives us 16. So that means we can go back up to the original problem, and we can plug in into the original problem, we can plug in 16. So remember, the number of dimes is going to be 9 less. So that means we have 16 quarters, right? Because Q is for quarters, so we have 16 quarters. And then how many dimes do we have? Remember, if you go up here, didn't it say it's going to be 9 less? So if you took 16 and you subtracted 9, because it said it was 9 less, that's going to give you 7 dimes. So Yardley has 16 quarters and 7 dimes, because we went back up to the top and we plugged in 16 for Q, and 16 minus 9 is 17. So we defined our variables, we wrote an equation, we solved that equation, and then we wrote our answer in a complete sentence. So make sure you're doing all parts A, B, and C. Okay, let's look at number 2. Number 2, William has $3.25 in a jar. He has 3 times as many nickels as dimes, and he has 3 more quarters than dimes. So notice that he's got more nickels than dimes, and he has more quarters than dimes. So we're going to let D represent the number of dimes, and it could be X if you wanted to. It doesn't have to be D, right? So it says we've got 3 times as many nickels as dimes, and we got 3 more quarters than dimes. So we're going to let dimes be our variable. So D for dimes. And then our nickels, it says we have 3 times as many nickels. So we have more nickels, 3 times what we have in dimes. So we have to say the number of nickels is going to be 3 times the dime. So 3D for 3 times a dime. And then the number of quarters is going to be 3 more quarters than dimes. So remember, 3 more than means it's adding 3 more dimes. So if you had 7 dimes, right? So if you had 7 dimes, wouldn't that mean you'd have 21 nickels? And wouldn't that mean you'd have 10 quarters? Because it said you'd have 3 times more. And then here it said you just have 3 more, right? So those are the expressions. So now let's write our equation. So before we do that, let's look at the value of each. So what's the value of a dime? So remember, the value of a dime is 10 cents, and that's how you write the value. And the value of a nickel is 0.05. Be careful, some people think it's 0.5, but that'd be 50 cents. So a nickel is 0.05, and a quarter is 0.25 is the value. Right, so now we can write our equation. So we have 10 cents times how many dimes we have, plus we got a nickel times how many nickels we have. And we have 3D in nickels. And then plus we have 0.25. And how many dimes do we have is D plus 3. And that value has to equal, right? The value has to equal $3.25. So all of that has to add up to $3.25. So this is your equation, right? So part A was to define your variables. So this is part A, defining your variables. Part B was to write an equation. And then part C was to solve that equation. And because I'm running out of room, I think what I'm going to do is start solving this equation by busting out the decimals. So I'm going to multiply the entire equation by 100, because if I multiply by 100, right, didn't we just learn in the last homework assignment, if you multiply by 100, doesn't it move the decimal twice? And doesn't that make each of these integer numbers or whole numbers? So then we don't have any decimals to work with. So that would be 10D plus 5 times 3D plus 25 times D plus 3 equals 325. So that makes it a little bit easier so we don't have to work with the decimals. So let's distribute and multiply. So we got 10D, and then 5 times 3D is 15D, and then we got to distribute, so that's 25D plus 75, right? 3 times 25 would be like 3/4, and 3/4 is 75, and then equals 325. So how about we subtract 75 from both sides? Remember, that's a 25. And at the same time, why don't we also combine these terms because they all have D's, so they're all like terms. So how many D's would that give us? So that's 10, 25, and 20. That's 50 D's. And then 325 minus 75. Take a quarter away, that's 300, and then take 50 cents away, that's 250. And then we're going to divide both sides by 50. And then when we divide by 50, can't I reduce each of these by 10? So when I divide this by 10, I get 25. And when I divide this by 10, I get 5. So 25 divided by 5, that's going to give me 5 dimes. So that means I have 5 dimes. Right? And so then, therefore, if I have 5 dimes, how many nickels do I have? So all we're going to do is we're going to take the D, and wherever I see a D, can't I put a 5 in its place? So I'm going to put a 5 where there's a D. And so doesn't that tell me, therefore, there's 5 dimes, and 3 times 5 would be 15 nickels, and 5 plus 3 would be 8 quarters. So that's our final answer. We could say William had. Right? It's kind of hard to write all that work in that little space, right? So basically we wrote the equation, we made variable expressions, defined our variables, wrote an equation, solved the equation using decimal busters, and then we wrote our answer in a complete sentence. Okay, let's try the next one. Okay, problem number 3. Samira went to the Orange County Fair. The fair charges $5 for adults and $3 for a child for admittance. That means to get in. The number of children tickets sold were 10 more than twice the adult tickets sold. If the Orange County Fair total sales was $250, so their total sales. So doesn't that mean, didn't they bring in money from all the adults coming in? Plus, didn't they bring in all the money from the children? The county fair. So if you add up all of the adults and the children's money that was brought in, it should equal 250. So we're going to make variables. So notice that to situation is adults and children. So because they said that there was 10 more, so the children's tickets sold were 10 more than twice the adults, then adults is going to be our variable. So we're going to let little a be the number of adult tickets. And then the number of children's tickets, right, is going to be 10. So 10 more than means to add. Twice, the word twice means to multiply by 2. And we're going to do that to the adults. So we're going to do 10 more than twice the number of adults, because that's what it says. It says the children's tickets sold were 10 more than means we have to add 10 to twice the adults. So we have to multiply by 2. So there's our variable expressions. And then how much money did they say an adult ticket was? So adult ticket was $5 and a student ticket was $3. Right, so that's the value of the tickets. So to write the equation, we have to say an adult ticket is $5 and we have A of them, plus a child's ticket is $3 and we have 2A plus 10 of those. Right, so we have to multiply how much money times how many we have, right? We have to multiply the money times how many have. And then So that's 3. Oy, 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 oy. So that's 3 and 2A plus 10 equals $250. So since I don't have to put the 0.00, right? I can just put 250. That's the same thing. And then we can solve that equation. So that's our equation. And then we can distribute. So that gives me 5A plus 6A plus 30 equals 250. Subtract 30 from both sides. That gives me 220. And then at the same time, let's go ahead and combine like terms, right? 5A and 6A makes 11A. And then that's 220. Divide both sides by 11. And that gives you A equals, doesn't 11 go into 22 twice with the 0 at the end, right? So that means there were 20 adult tickets. So we replace, wherever we see an A, we're going to replace it with 20 because now we know there are 20 adult tickets, right? So therefore, there would be 20 adult tickets. And then 2 times 20 is 40, and 40 plus 10, that'd make 50 children's tickets were sold. Right, so always write your answer in a complete sentence. So notice how we took the 20 and put it in where the A was, and then we can figure out how many adults, which we already knew, and how many children. Okay, let's look at the last one. Okay, last problem. So Eric and Anthony were playing Mario Brothers video game. Every time Eric kicks a shell, he earns 2 points. And every time he collects a coin, he earns 5 points. The number of coins collected was 4 more than 3 times the number of shells he kicked. If Eric earned 71 points, how many coins did he collect? So the total number of points, just like the total sales, just like the total money they had in the piggy bank or had in their purse, or the total amount of money that the Orange County Fair brought in, the total amount of points he made was 71. So 71 was his total points, right? The total points that he earned. So we want something that equals that. And then what is the problem about? The problem is about 2 things. It's about the fact that he's got shells. So it's about shells, and he earns 2 points for each of those. And it's about collecting coins, right? So it says right here that he collects the number of coins. So the number of coins collected was 4 more than, so remember more than means you're going to add, and we're going to 3 times the number of shells. So to figure out how many coins we have, it has to do with how many shells there are. So we're going to say, let's let X represent the number of shells. I just didn't want to use S for shells because S looks like 5 a lot, so I don't like to use the S because it looks too much like a 5. And then the number of coins that he collected, it said 4 more than, so it's got to be 4 more than means you're going to add 3 times the number of shells. So it's 3 times the number of shells. So I used X for shells. And then how much is a shell earns him 2 points, and if he collects a coin, he gets 5 points for every coin. So 5 points for every coin, 2 points for every shell that he kicks. So this is called our defining our variables. Now we're going to write an equation. So the number of shells plus the number of coins has to equal 71 points. So remember, I have to turn those into points. So a shell is worth 2 points each, and a coin is worth 5 points each. So we have to put what the value, right? We have to put those values, and those values have to be multiplied by how many we have. So that's our equation. And now we have to solve that equation by using the distributive property. Right? 5 times 3x is 15x, and 5 times 4 is 20. Then we can combine like terms. Right? These both have x's, so we can combine those and say we have 17x plus 20 equals 71. And then I'm running out of room and erase this a little bit. And then we have 17x plus 20. Subtract 20 from both sides. And that gives me 51. And then divide both sides by 17. And then, let's see, I have a funny feeling that that goes in evenly. Let's see, what is 17 times 3? Because 3 times 7 is 21, and that's good because that gives me a 1. 3 times 1 is 3, 4, 5. Yep, it's 3. So x equals 3. So what did x stand for again? Do you remember? So x, if you come back over here, what does x stand for? X stood for the number of shells. So if you replace the x with 3, doesn't that put a 3 there? And doesn't that put a 3 there? So doesn't that tell us that there were 3 shells? And then when we work this out, doesn't that give us 9 plus 4? Doesn't that give us 13 coins? So now let's write our answer in a complete sentence. So we have 3 shells. So he kicked 3 shells and he collected. 3 times 3 is 9 plus 4, 14. 9 plus 4 is 13 coins. So he had 3 shells, and then 3 times 3 is 9, and 9 plus 4 is 13, and so that makes it 13 coins. So that's why it's really helpful if you have this first statement, which is define your variables, because you can always go back to that, and then you could just plug in for the letters, and then it tells you how much of each you have. So word problems are tricky, they're confusing, they're stressful, but as you try them and then you work with the teacher the next day, or you go back and watch a video, you go and look at notes, you start to get better at them. So it's just something that it doesn't magically happen. And you have to read the problem often, and you have to like underline things and say, you know, there was, they collected coins and there was 4 more coins. So more than means you're going to add. And then there were 3 times the number of shells. So you had to do all of that. And that's where this statement right here came from. Right? So it can get kind of confusing. All right, you might want to rewatch this video again.